Alright, we are back and we are ready. Before we move on, we need to go over how to simplify radicals. So this is a pretty big topic that you learned about in Algebra 2. So I'm going to put this into two parts, and so that way you can stop, think a little bit, practice, and then come back. So the first thing we're going to do is review how do we actually simplify a radical. And we did this at the very beginning of the year, but I thought, hey, let's review real quick. So if you recall from simplifying, let's say that you were asked to simplify the square root of 140. So to simplify the square root of 140, what I think the easiest thing to do is to make a factor tree. And if you remember, I told you it's a story about 140 being stuck in what you may consider to be a jail. So the square root is like a prison. And so if we make a factor tree and we split this into 2 and 70, and then split the 70 into 2 and 35, and then you can split the 35 into 5 and 7. So now what you do is you look at the ends of your tree. So you're not going to look at the 140, the 70, or the 35. You're going to look at the 2, 2, 5, and 7 and see if you have a pair. And since we have a pair of 2's, that means that the 2 can break out of the prison or out of the radical and become a single digit on its own. So it will come out of the radical and be 2 square root of, now we still have the 5 and the 7 left inside, so since they don't have a partner, they're going to stay together, multiply them together, and you'll get 35. So the reduced radical form of the square root of 140 is 2 radical 35. Alright, what if you have something that's outside the radical already? So what if you had something like this that said 3 square root of 200? Do the same thing, leave the 3 alone, and break down the 200. So we'll break down the 200 into 2 and 100. Now there's other ways you could do it, but that's just what my brain saw was 2 and 100. And then the 100, I'm going to think of breaking it into 10 and 10 because the 100 is a perfect square. So since we have a 10 and a 10, I know that I can break the 10 out of the jail. So since the 10 can break out of the radical on its own, I'm going to take the 10 and I'm going to multiply it by what's already out there. So that'll be 10 times 3, which is 30. And then I have the 2 left inside. So the 2 doesn't have a partner, it's going to stay inside the radical. So the simplest form of 3 squared of 200 is 30 square root of 2. Now the last thing to simplify, which I know we didn't talk about too much, is what if you have variables on the inside. So let's say that you have the radical of x squared and y to the 5th. Now, in case you forgot, x squared actually means x times x. And y to the 5th really means y 5 times. So y times y times y times y times y. So this is the same concept as what you just did with the factor tree, only partners can break out. So since the x is a pair, the x squared is a pair of partners, it can break out of the radical and become on its own as just a plain x. The y's then have 2 groups of partners. So since there's 2 groups of partners that can break out, it will be y squared, 2 y's. Now we still have this y left on the inside that doesn't have a partner, so your answer will be x y squared times the square root of y that's left on the inside. So that's how you deal with a variable. Now let's look real quick at adding and subtracting. And then we will pause and take a break. So the second concept will be adding and subtracting radicals. So when you add and subtract radicals, there's 3 things to remember. Alright, number 1 is going to be that you can only add and subtract if the radical is the same. So it's kind of like a variable. If they don't have the same radical, you can't add them together. Same thing with x's. You can't add x's with y's. Also, when you do this, you're going to add the outside numbers only. And then you will leave what's inside the radical the same. So leave the radical the same. So let's say, for example, that we have the 2 square root of 5 plus 8 square root of 5. So we can definitely add these together because the radical square root of 5's are the same. Now when you add them together, the second step is you have to add the outside numbers. So we're going to add like the coefficients together. So 2 plus 8 gives me 10. And then the radical 5s are going to stay the way they are. So it'll be 10 square root of 5. That's all you have to do to add. So for example, let's say that you had something like 2 square root of 2 minus square root of 3 minus the square root of 2. So if I look at this one, I can only put together 2 square root of 2 and negative square root of 2. And this is just like an x, so there is an imaginary 1 in front. So 2 minus 1, the coefficients, 2 minus 1 will give me 1 square root of 2. And now negative square root of 3 doesn't have a partner, so you just tack that on the end like you would a regular variable that doesn't have a partner. Alright, last one that you may come across is this. So what happens if you see the square root of 8 minus 3 square root of 2? And I know you're thinking to yourself, I can't add these together because the 8 and the 2 do not match. So I'm done. I don't have to do anything else. Wrong answer. Actually, you can break down the 8 more, unfortunately. So we'll break down the 8, and that will be 4 times 2, and then we can break down the 4 as 2 times 2. And look at that. You have a pair of 2's that you can break out of that radical. So now you have 2 square root of 2, because there's a 2 left right here, and then bring this guy down as minus 3 square root of 2. So never assume that just because they have different numbers that they can't be added together. So you want to try to simplify. So now what you have is putting your coefficients together. 2 and negative 3 is negative 1 square root of 2. Or you can write it as just negative square root of 2. Alright, now what I'd like you to do is hit pause, and you go ahead and try the first 2 sections on the worksheet that you are about to get.